which they might do on these slides, they definitely do it in the book. So if you wanted to remember the proof, that would be fine. Or you just remember this fact. So the derivative of ln of x is what? 1 over x. So that tells you the slope. So for example, when x equals 1, right here, what is the slope going to be right here? So there's a tangent line right here, right? So the question is, what is the slope? So how do you find that out? You put 1 into the derivative. So what is the derivative? 1 over x, so you put 1 into that, you get 1. So the slope right here actually is just 1. Okay? And then the slope at other places is different. Right? Yeah. But it doesn't, because the derivative formula, what is the derivative again? What does it say? It says it up there. I circled it. 1 over x, right? It doesn't add, the derivative formula doesn't need y in it. It doesn't require us to fill in y, right? It just requires us to fill in the x coordinate, right? Okay? So it tells us, if we put in the x value, it tells us the slope, right? It doesn't care, this derivative formula doesn't need the y. Now, there are some cases, which we skipped over in our course, where the derivative formula has y and x in it. So you need, if you want to know the derivative at a particular point, you have to put in not just the y, not just the x value, but the y value. But those are sort of unusual cases. Usually for the derivative, we only need to tell it the x value. Okay? So it doesn't matter what y is here. Right? It's just, I mean, the derivative doesn't depend on y in this, or our formula. You could write the derivative, you could say, oh, the derivative definitely depends on y, just like it depends on x. Right? If you choose this y, you're here. If you choose this y, you're here. So you could say, certainly, you could probably come up with a derivative formula that includes y, or that needs y. But fortunately, you could say fortunately in this case, we don't even need y. We just have to put in x. Okay? Is that okay? No. What do you think about that? I mean, do you think it should? Looking at the picture. So is this slope the same as this slope? No, of course not, right? So, well, what is the derivative? It's 1 over x. So does that always remain the same? No, it depends on x. Right? So a little bit more, as x gets bigger, what happens to the slope? As this gets bigger, what happens to this? It gets smaller, right? And what about the picture? As x moves this way, what happens to the slopes? They get less, right? Okay? Okay? Now, okay, so we know the derivative. Okay, so what is the derivative of the ln function? What is it? 1 over x. Okay, so there's like a few that you should basically just remember. Okay, you really, if we had the time, we go through the proof, and then, I would say, no, just, prove it. But, that generally, after doing it a few times, you'll end up remembering it anyway, right? And, just going through the whole proof each time takes a long time to go through the proof, so you wouldn't do that actually anyway. Okay? So, now, how about this problem? This one here. So, let's see. If we have, can't write with this thing. We have, let me see, the derivative of k at, I don't know what happened to these systems. possibly happen? This used to work. Maybe they changed the build of Windows on here. Maybe some recent update to Windows screwed this up. Yeah, but they apparently did something wrong, I think. Let's see again though. Okay, let me try once more. The derivative of K F Okay, we had a formula for this. Let's see if I can write it here. No. How about here? Equals? No. Okay. That's as much as I can do. Okay, what's the answer to this? When you take a constant times the function and you want to do the derivative, what's the rule? The rule is that you can take this and move it outside. Okay, you can take the k outside and just say, oh, it's k times the derivative of f. Okay? That's what they're doing here. The derivative of 3 times ln of x is what? 3 times the derivative of ln of x. Okay, which is 3 times 1 over x, which is 3 over x. Okay, everybody understand that? Now here's one more formula. Unfortunately, this one's a little bit more complicated. So here, we're talking about the derivative not of ln of x. This is what? Log base b of x, right? Okay? So that's, which is more general? This formula or the derivative of ln of x? Which is more general? This formula includes the case of ln of x. Why is that? Because b can be anything, including e. Right? So this also will tell us the derivative for ln of x. Right? The previous slide said that the derivative of ln of x was 1 over x, right? Okay? But that's a special case of this formula. Because this is for any b, not just e. Right? ln means base e, right? This is for any b. So this will work even when b is equal to e. When b is equal to e, what is the derivative? 1 over x, right? So is that true here? When b is equal to e, do you get 1 over x? Yeah, because what is ln of e? I wrote it on the board. ln of e. ln of e is 1, right? So when we put in e for b, we get ln of e here, right, which is 1, so we just get 1 over x. Okay? See that? Okay? You see it or not? No. This is the formula for any b, right? And what I'm saying is that this is only for the ln function, right? Means the log base e function, right? Right? ln means the log base e, right? And that's what ln means, the log base e. So this is only for the log base e. But this is for the log base anything, any b. Okay, so this is more general than the previous one, right? The previous one was only for base e. So this should give us the same answer as the other one when we use e for b. Does it? Well, when we replace b by e, what's this part give me here? Give me 1. So it gives me 1 over x, right? The whole thing is 1 over x, which we said what it should be. Okay? So this is a generalization of the previous rule. Okay, so this is the derivative for any base. Okay, so the derivative for any base, b, is what? 1 over x and ln of b. Okay? All right, so that's the derivative. You can use this for any base b. So here, if you want to know the derivative of base 3, the answer is 1 over x ln of 3. Then you have to figure out what ln of 3 is, and you get this answer. Okay? So which one is more general, this screen or the previous screen? This screen, right? This includes the previous screen, right? Because this is for any b, including the previous screen's case, which was when b is e. Okay? Okay, now they give us the how you can derive it. So, should we do that? Let's see how hard it is. How can we do this before we look at it? We haven't actually, we did at the very beginning, we found out the derivative of x squared. We did it. Like, of course I told you a long time ago that you can just use the power rule, right, to get the derivative of x squared. But then, when we were beginning to talk about derivatives, we actually proved that the derivative of x squared is 2x. And how did we prove it? What did we do? We had to use the definition. We had to use limits. Maybe you don't remember, but you can go back to our videos on YouTube and you can see it. Okay? So I think we're going to have to use limits here to show this 1 over x answer. So let's see how they do it. Yeah. Okay? So you see, you have to say, oh, this is the definition of limit. And then we put in specifically ln of x here. So we put ln here and ln here. And then we push through, doing algebra and keep going, and finally we get here. Okay, finally we get that the result is 1 over x. So let's see that once more. We want the derivative of ln of x. We use the definition of derivative, but specifically we put in the function. Like usually we have f here and f here. That would be the definition of derivative of a function f. But now we have to put in specifically the ln function for instead of f, and then we just keep doing some algebra and some more. Here they use a property of the log function, and then the next screen brings us here. We do some more algebra, another property of log functions. We get to here, we get to here. We end up with this and here, and finally we get 1 over x. Okay? So finally we prove that this statement back here was true. The derivative of ln of x is 1 over x. Okay? So if you want to go through those steps, they're not very hard. Just a little algebra and properties of logs. Okay? So it's not very hard. You can go back and you can look at it on the internet. I'm sure you can find it in 100 places. And you can see how to prove that. Okay? Okay. Now they do this, but I never did this. This is an example of the chain rule, but they write out it kind of specifically like this. But let's just use the chain rule to get the derivative of this. Okay, so if we're going to use the chain rule, then we have to have an outside function and an inside function. So looking at what I underlined with red, do you see an outside function there, and do you see an inside function? So what would the outside function be? The ln function is the outside function, ln of something, right? So it's ln of what? Of x squared plus 1. So the inside function is what? X squared plus 1, and the outside is doing ln of that. Okay, so we do have an inside function and an outside function, right? So we could use the chain rule, right? So the chain rule says, take the derivative of the outside function, right? And then put the inside function into that. And then there's one more piece to the chain rule, which is what? Multiply it by the derivative of the inside function. So the derivative of the inside function is easy. What's the derivative of the inside function? Just 2x, right? So that's this piece here. That's the derivative of the inside function. And we have to multiply that by the derivative of the outside function. What is the outside function? ln. What's the derivative of ln in general? 1 over, right? But it's not 1 over x, it's 1 over this thing. So it's 1 over that thing times the derivative of this, so that's 1 over this thing times 2x. Okay, and so this is what we get. Okay, so we can use the chain rule to find this derivative. Okay, and we wouldn't have any way to find this derivative other than using the chain rule. Okay, you need the chain rule. You need to say there's an outside function and an inside function. Okay? Now, how about this one? This is worse. Anybody get the idea of what we're going to have to do here? We're going to have to use the chain rule twice. Because we have one outside function, then we have another outside function, and then we have an inside function. So we're going to have to say, there's an outside function, and then this is the inside function of this whole thing, but then when we have to do derivative of this whole thing, we're going to have to use the chain rule again. Right? You understand? So let's say it again. Where's the outside function here? ln, right? So we're going to do what? We're going to say the derivative of the outside function, right? Evaluated at the inside function. Okay, that's all okay. That's nothing new. Okay, but then the last piece is what? The derivative of the inside function, right? But what is the inside function? It's the square root of x plus 1, right? But when you do that derivative, you have to use the chain rule again, right? So you're going to end up using the chain rule twice here. Let's see how they do it. So we take the derivative of the outside function means what? The derivative of ln. So it's 1 over whatever is inside, right? So that's 1 over, that's this part here, right? But then what? Times the derivative of the inside, which is the derivative of this, right? But how are you going to do this? How are you going to do that? You have to use the chain rule for this again, right? You get it? Okay, so they'll end up having to use the chain rule twice. Okay? All right. Okay, so now we have, okay, what about this? You already know this one, right? The derivative of e to the x is e to the x, right? You know that. Okay, they proved that. Okay, let's look at, what time is it? What time is it? 3:49? Okay, so we're finished? Okay, so let me just review once more. Okay, so we did now, okay, by the way, so what did we do? In terms of homework, we have done, we've done derivatives of logs. So that is due on July 4th, and you should be able to do that now. Okay? And actually the chain rule is after that for some reason. Okay? Now, here we have some applications of mins and max. So anyway, hopefully, maybe next time we'll shift gears and do the integral. Okay, then we might come back to derivatives again afterwards, since we have a lot of time. Okay, but we might just do enough to cover this homework assignment, and then come back to. Okay, but once again, don't forget you have the Coursera course. We're going to have a quiz on that, and the information is there. Due July 4th, Coursera Data Science Math Skills, first week quiz on that material. And remember, you do not have to pay. And there's one quiz where they ask, if you want to take that one, they make you pay. But you don't have to look at that quiz. Okay, so you definitely don't have to pay. All right?
What?